I'm going to show you the feature, the event stream feature. This is.
So really quickly though, when we just installed an agent, we installed that agent on a guest in Azure, right?
Yes.
Naturally, we're not going to have insight into what the hypervisor host on Azure is doing itself.
No.
In what ways are we limited as a result of that? In what ways are we limited in what we can see in the whole platform because of that guest usage, I guess you could say, guest agent usage?
Yeah. So, I mean, you only know what's happening inside the guest.
Sure.
I guess.
But the benefit is that what are you using that guest for, right? If you're, let's say if you were to use it for a host for some containers, then you would be able to see insight into how those containers are sharing the resources you do get. If you're running maybe just a single legacy application in it, you would at least have monitoring and awareness of the host resources consumed by that application, because although we have a strong focus on infrastructure and for operators, we view our tool also useful to application owners as well. They can log in if an operator sets up an OpenStack cloud, gives you credentials to create VMs. You're not an owner of the infrastructure, but you're a tenant inside that cloud. You want to run your applications. You want to know how your applications are performing. You want to know, is my application using too much memory? Is it growing in memory, maybe leaking, or storage running out, and I need to ask my operator for more resources or go self-service. So even in the Azure case, you would be able to see that, oh, maybe my application is kind of peaking the performance of this instance, and I might want to spin up another Azure instance, or I might want to look into debugging my application to see why it's maybe leaking memory or something.
Yeah, but
so in your example, you deploy the agent to a Linux VM running on Azure, but that could be a Windows VM.
It could be a Windows VM too.
Is the idea in the future that when Windows comes out with containers in 2012, this will be the one you'd want to monitor the containers with? Because to be honest, there are a million Windows monitoring tools out there. Yeah,
absolutely.
Why would somebody pick you guys for Windows monitoring, for example?
So for the hybrid cloud scenario, our primary scenario is people spinning up containers within those VMs, and that's when we are helpful. But if you are to go look at Azure, right, and you say, hey, Azure, show me metrics for my VM even, it's going to give you that high-level CPU network. It's not very detailed, right? It's just kind of proving to you that the thing is running, but it's not doing anything more than that. You put us in there, we give you everything. Like you get down to like what the storage I/O is like, what's the rate, what's the what are the errors on the interface, everything. So that coupled with this move towards containers and people spinning up containers in these cloud environments, that's when the scenario kind of blooms and it becomes really useful.
So I'm gonna get greedy.
You have to give it over to the cloud providers. You've got to realize that when you're provisioning in Azure, they're responsible for the boxes, and you have to let go of that control and say, okay, I trust you guys that you are monitoring your physical resources, and I'm just provisioning to use a section of that. But as you said, then you go and add the monitoring to go, okay, well, of the memory that I've provisioned for my instance,
yes,
how is my performance and my capability going within that sphere? And I think it's one of the hardest things for box huggers to do is go, I actually don't need to see that low-level hardware stuff because I'm paying for somebody else to keep all that under control.
So, and in that same spirit, right? So, what we've designed for the enterprise then is that same role-based experience. When the admin logs in, he gets those low-level system metrics, right? Like when the operator logs in. But when a user logs in, he's only getting to see his VMs. He's not getting to see, hey, what's happening down below, in the underlying infrastructure. In some instances, when we've gone in, the enterprise has actually told us that, hey, can you please expose some of these metrics to the users so that it reduces the number of calls that we get? For example, look, our users should be like working with each other, and if one is stepping on somebody else's toes, let them know who it is so that they can figure it out amongst themselves and we don't get the calls. So we are getting some of that as well.
So I guess that's the next question. I want to get greedy with this. And let's say that I have a container host running on a KVM machine. So I have the agent installed on the virtualized container host. I have the agent installed on the physical KVM host. Is there a way to correlate the two abstractions with each other?
Yes. You just saw that, right? So
Yeah, so that's sort of what we were demonstrating, right? That fact that we had put our agent on Azure,
Right.
and we're showing you the data on the same screen as data from your on-premise cloud.
No, so not that, but let's say that it's all on premises.
On private.
It's all on premises, and I have a KVM host. I have the agent on the KVM host. I'm running a VM on the KVM host itself.
Yeah.
That's a container. That's a container host.
Right.
So I have the agent on that VM.
Yeah.
Yeah,
And I
so
want to
that-
correlate.
Work exactly the same way.
will
Though.
work
My
exactly
point.
the
My
same
point
way.
is, if you just imagine taking that Azure VM, bringing it in house.
Yeah.
Nothing's changed now. The communication is still, we're able to show you now what's happening with your containers inside a virtual entity, and we are able to show you what's going on the physical layer beneath that virtual machine.
So I guess that's the piece I missed because I saw the three different components. It was Azure host, a Azure container host, and the 2 KVM hosts, but there was no correlation between the 3. Like if I have a poorly acting app in my container that's running on the KVM, the admin, I want from an administrative perspective, I want to know if I see an alert on my KVM host, I want to be able to drill down to that container host to know that it's the container host, and then what inside that container host, what's acting up.
So, okay. So when that's absolutely right, and that's what I meant by when I said context, right? So when we are putting these events out on the bus, we are trying to already pre-populate all of those fields for you. So if we know that, hey, if we know where it's triggering, from there we trace it back to the VM. We can trace back the VM back to the host. We can trace the VM to the user, and we pre-populate all of those fields in the event rule. So when we set one of these event rules, and when you see it, I mean, you'll be able to see that.
Okay.
Yeah. So the event stream is really part of the processing that we're doing in our agent. So at the point of collecting the metrics, we are doing whatever monitoring policy has been pushed out to the agent. So we would collect the data and then analyze the data and decide, is it crossing threshold? Is that, if that threshold is based on static value or baseline, dynamic learning, the agent would be told the policy and then take that metric and decide, do I need to send an event up because of data I've recently collected? And this is a kind of slightly different approach than what a lot of traditional monitoring tools do, which is just get a bunch of data and put it on the wire. And then somewhere that syncs into a big database somewhere, and maybe you churn over that data with a Hadoop cluster or some lots of compute power. So we're trying to take this and build it in a way that grows and is distributed with your infrastructure, so that as you're adding compute nodes, we're scaling with the size of your cluster.
So I really like the way that you use all the agents. Thought that was very sexy, by the way. Well done, good job. What I'd like to know is, how do you decide on when I have a risk? So out of the box, I've installed my agents, which again are sexy, well done. How do I know, or how do you decide a risk to my infrastructure? What's your common baseline metric, and how did you decide it was a risk in the first place?
So it was based on customer experience,
Okay.
to be honest. So the early deployments that we did, it was direct feedback from the customers that said, hey, focus on these few metrics. It's a combination of, let's say, what the behavior of your swap memory space is, what the CPU load is, and things like that. So direct feedback from customers
Okay.
is what enabled us to figure those things out.
Thank you.
And we're doing lots of speeds and feeds, but it would also be good to see, seeing its AppFormix, from an application point of view, or what benefits you giving to the applications. Because we can look at CPU and
Let's get there.
Yeah.
Let's keep going.
I'm worried.
Right. So how the event stream works is basically you configure the policy that says, I want to generate an alert. This is an example. Generate an alert for CPU usage if the average over a 5-second interval is greater than 50%, and then we don't want it to be too noisy, so we allow you to say, within the last 3 or 4 intervals, whatever number you want to say, that I want to see this as a sustained problem, not just a blip. And the way that looks is if you imagine a graph of CPU usage, and you can see here it's hovering just above 50%. We have two types of events we can generate. One is an event that triggers every time you see an interval that matches the criteria. The second is a more stateful, what we call an alert, and that says, I'm active when you first enter a period in which you've crossed the threshold, and then I'm inactive when it subsides. So here you would see that after there's 3 intervals which have CPU above 50%, we would generate either an event if it was configured as an event, or we would say the alert is active. And then as time progresses, when the CPU subsides, after there's not 3 out of the last 4, then the event stops being generated or the alert becomes inactive state. And so the alert is sort of, you get an event when it comes active, and when it comes inactive, you get notified of the state change. The event is something if you want to just be logging every single time. And then we're going to show a demonstration of that on the Mirantis. So where's this one?
Did you already configure PagerDuty? Do you want to show that first?
Sure. So one integration that again, this architecture supports listening on the bus, right? One thing we've done is actually integrated with PagerDuty as a listener on the bus, such that when an event is generated, our PagerDuty plugin will take that event and send it to PagerDuty. We first get your credentials, your PagerDuty account, and then once we have those credentials, when the event is received and it's the little PagerDuty plugin sees an event on the message bus, then it's going to generate a REST API call to PagerDuty to let you know that there's something going on with your cluster.
Do you have plans to integrate with any of the other IT service desk ticketing systems like Autotask and ConnectWise? And
They are asking us to.
Yeah.
So the one we worked on is Slack.
Yep.
Mm-hmm. That's one, but we were just at this other DevOps summit where there's a lot of other interest. But once our customers demand something, then we'll do it. PagerDuty was directly asked for by customers, so was Slack. So those were the we worked on first.
While you're doing that, can I just ask a question about application? So we've just been talking between us all, and you would have heard any or seen any of that, because it was all gone on Twitter. We're talking about actually looking at the application itself. So metrics that are tracking not the VM running, not the CPU or the memory the VM or the containers consuming, but the actual application, which could be a database, could be web server. How are you going to show that? Because we don't really sort of see that in the demonstrations.
So that's a good question. And sorry. We're gonna
give you a mic. PagerDuty alert. You have 2 triggered incidents on AppFormix Incorporated.
Nice.
Press 4 to acknowledge all incidents. Press 6 to resolve all incidents. Press 0 for help or press star to repeat this message.
So basically, what we have enabled here is like self-service for you. Like you can set up an alert in any time on any of the different metrics. Right now, I just went ahead and set up an alert for CPU over 70% on the entire infrastructure. So it could be like 1 host, 2 hosts, or like hundreds of hosts. And you can do that across a project or across tenants. And you will instantly, with PagerDuty, get notification on your phone, email, mobile, like on all platforms.
And if you see the event rule there, there's columns there for like the host name, the project name, the instance, the vport, the meta name. So as and when applicable, right, all of the context information is added there. So right now this was just an event on the host. So the only thing that's populated there is the host the event happened on. If it was an instance, that would appear there as well. So, and that's how we kind of use the context and make these events richer.
And the way we define the policy is that when you create a rule, it applies to a certain scope. So you would say this rule applies to a project. Then in that case, what you're monitoring is the instances that belong to that project. And you write the rule once, you don't have to configure every single instance. So as new instances may be added or removed from the project, that same policy, that same event rule is going to apply to all instances, or similarly all hosts in your infrastructure or in a host aggregate. So that way, you can define the policy once and then let it grow dynamically with your changing infrastructure.
Yeah, and one other thing to keep in mind. So, we of course have the charts where you can visualize many things, but the number of metrics you can actually analyze is far greater than the number of metrics you can even visualize in the chart. So for example, one thing again which was like directly requested by customers is now that we are enabling large storage farms using commodity drives, was to do predictive monitoring of predictive smart monitoring of hard drives.
Okay.
And SSDs. And so we have that built in as well. So like right here, you can see that I can set an alarm that monitors, all of the nodes or a subset of the nodes in my infrastructure, monitors the hard drives on those nodes and generates the alarm if we feel that, hey, a particular hard drive is going to fail on that node. And we give you all of the information, what node it is, what hard drive on that node, and things like that. So again, this is where having the agent on the host becomes really useful, because imagine that if I was to actually start exporting all of this data from the host, how much data it would be, especially if I was doing it frequently. Now, because we're sitting directly on the host, we can always be reading and we can always be analyzing without the need to export that data.
So do you also know how an application behaves? Because this seems pretty standard. You cross a threshold and then you give an alert. But can you make is there something in it that you can say, okay, it's Monday morning, I know it's high, but it's Monday afternoon, now it shouldn't be high, and then I give an alert?
So currently in this alarming system, we do not compare to historical baselines, but that's definitely something we need to get to, right? It's something we need to build out quickly because it's requested by a lot of users.
How far can you go into a storage array, for example? Can you look at the array itself and the HBA queue depth of an array, for example?
We are looking at queue depths.
Okay.
And in storage arrays, sometimes it does matter what RAID interface is in there and what it allows us to do.
Yeah.
But as far as sitting on host nodes, we do look at queue depths.